Okay, so we're going to do surface area of a cylinder today. So I want you to have a think about what happens when we're looking at a cylinder. Okay, so this is what a cylinder looks like. All right, we curve that piece of paper around. So if you look at a cylinder, most of the time what we're doing for maths, if they don't tell you about the cylinder, we always assume that it's closed. All right, now closed means it's closed on the top and it's closed on the bottom. So when we're looking at trying to find the surface area, we're going to find the area of the circle at the top. We're going to find the area of the circle at the bottom. So that's pi r squared plus another pi r squared. So that gives you 2 pi r squareds. That's for the top and the bottom circles. Those surfaces we call flat surfaces. All right? Now, this bit that goes around, like a label around a can, is called the curved surface. It is curved. The circle on the top is not curved, and neither is the one on the bottom. But this is curved. Okay, and to find the area of that curved surface, we have a look at unwrapping the label around the can. All right, so if you look at it, I've actually put an H here. So this is actually showing you the height of my cylinder. Okay, now this top piece here, that piece around the top, that would be 2 pi r to go around there. So if I unwrap it, okay, that was the height of my cylinder, and when I curve it back around, you'll see it is the height of the cylinder. When I unwrap it, that's the height there. Okay, now this bit here, I've written 2 pi r there. That's because when I wrap that back around, it is the circumference of the circle. So see when it's coming around? So you can see that it is actually 2 pi r. So if I want to find the area of this thing, which is the curved surface, when I unwrap it, it's a rectangle. So to find the area of this rectangle, I'm going to go length times breadth. So I'll be doing 2 pi r times the height. Okay, so let's have a look over here. If it's closed, we have a top and a bottom circle. We have 2 pi r squareds, top circle and bottom circle. That's those areas done. Plus, we're going to add on the curved surface. Okay, so remember, this bit here is the circumference of the circle, and when we unravel it, it actually appears here. It's that piece there. The height of the cylinder here, that's the height. When we unravel it, it's here. Okay, so remember that this is really a rectangle when you unravel it. So it's 2 pi r times h, and that's what that bit is. So that's what we call the curved surface. Okay, so if it's closed, we have a top and a bottom circle, so it's a pi r squared plus a pi r squared, giving you the 2 pi r squared there. If it's open at one end, it means that one of those circles is missing. Now, often it's the top, okay, because you might have an open can or something. You've thrown the lid away. So the top might be missing. That means you've only got 1 pi r squared. So our formula becomes pi r squared plus the curved surface, which you still have, 2 pi r h. If it's open at both ends, so if you look at what I was showing you a minute ago, right, this was actually an open cylinder, right? There really is no lid there. There's no top or bottom circle. So if I was finding the surface area of this, it's like a pipe. It could be a water pipe or something like that. I'm finding the surface area. I'm only finding the curved surface area because there is no top or bottom circle. Okay, so that means we would just have 2 pi r h if it's open at both ends. Okay, so obviously the r is the radius, the h is the perpendicular height. That's the same as any other formula that has an r or an h in it. All right, so we're going to go through some of these questions and see how we go. So to start off with, we're finding the surface area of a cylinder. Now they haven't said, but we always assume it's closed if they don't tell us anything. So we're going to use the full formula with 2 pi r squared for our 2 circles, top and bottom, plus the curved surface 2 pi r h. So subbing in, we're going to have 2 times pi times the radius, which is 7 squared, plus 2 times pi times the radius 7 times the perpendicular height 10. Put the whole thing in your calculator like that. Your screen should look identical to that. Press equals at the end, and that's the answer you will get. We're rounding to 2 decimal places. There's 2 decimal places. This is 5 or more, so this will go up by 1. Now, can't really go up by 1. It's going to a 0, so this will go up by 1 to a 7. Copy everything else. And we've got metres squared on the end for the area. Okay, the next one. Start again. We've got a closed cylinder. 2 pi r squared plus 2 pi rh. This time they've given you a diameter of 6.2. So to find your radius, you're going to get your diameter and divide by 2. So our radius is 3.1 that we're going to be putting in for this question. So we have 2 times pi times 3.1 squared plus 2 times pi times 3.1 times the height, 7.5. And if you put all of that in your calculator, that's what you'll get. We're rounding to 2 decimal places. The 5 means we're going up by 1, so that will be a 7. And there's your answer, metres squared on the end. Okay, the next question, number 2. We are finding, now be very careful with this, all right? In tests, you've got to read the question carefully. This one said find the surface area. This one says find the curved surface area. Now that's really important. The curved surface area is the label around the can. So we're only looking at 2 pi rh. That's the curved surface area that you're finding. Okay, so we're subbing in 2 times pi times, now they've given you a diameter of 9, so our radius will be half of that. Okay, so you're going to have to get 9 divided by 2, half of it, and you'll get 4.5. So we're putting that in for our radius. So it's 4.5 and times the height of 32. That's the answer you'll get. And then we're rounding to 1 decimal place this time. And that will take us up by 1 here to an 8. And here's your answer, centimetres squared. Okay, now these next two, again, be very careful, read what it says. So what we have here, we're finding the surface area of what we see. Now, this is a semicircle at the front and a semicircle at the back. So it's a semicircular prism. Okay, so now they tell you it's open at the top. Now the top they're talking about is this rectangle at the top here, right? So it's a little bit like if you've seen a horse that eats out of a feeding trough or something, then it's open at the top so that they can actually eat the food that's there. All right, so that's the type of thing we're talking about. So we're finding the surface area of what we've got. So there is no rectangular top. All right, so what we're going to do first is look at these two bits. Now they are both semicircles. So if you've got a semicircle and a semicircle and you put them together, you'll get one whole circle. Okay, so what we're going to do is just get pi r squared, and that will take care of the two semicircles. So now we're going to do our curved surface part, which is actually a half of the whole curved surface. Okay, so we're going to do a half of, now the curved surface area formula is 2 pi rh, remember? We're doing half of that. And now we're going to work everything out. So sometimes boys go, oh, but if I'm doing half of 2 pi rh, can I just write pi rh? Yes, if you know what you're doing, you can. Just make sure you're not making any mistakes. Okay, so I'm just going to sub straight into what I've written up there. So we've got pi times, now the radius of this, that is your diameter, the 1.2. So our radius will be the diameter divided by 2. So your radius will be 0.6. So that's what we're putting in up here for the radius. Squared plus a half times 2 times pi times radius is 0.6 And the height, you've got to imagine this turned up the other way. The height will be 2.85. It's going to come away from your base. So if your base shape's that semicircle, it's the part that comes away from it. So it's 2.85. And that's what you'll get for your answer. And we're rounding to 1 decimal place. So it's going to be 6.5 metres squared. Okay, next one. This also has a semicircle up there at the end. And they've got one at the front as well, but it looks a bit missing. So if you read what it says it's open at the top. That means there's no rectangular top. And one end is open. That's what they're trying to show you there. There is no end. Okay, it's dropped off that piece or whatever. So we're finding the surface area of what's left. All right, so we're going to start with this bit. It's always best to start at the ends, the base shapes. So that piece up there is a semicircle, so that's a half of a pi r squared plus. Now we're looking at the curved surface, but that curved surface, remember, is only half of the full curved surface. So we're going to write half of 2 pi rh. And now we're going to sub in, so we've got a half times pi times, now your radius, again we've got a diameter here, so we're taking our 1.5 and dividing by 2, and that will give you 0.75 for your radius. So I'm going to put that in for the radius, and it's squared plus a half times 2 times pi times the radius again, times, and remember our height comes away from the base shape, so it's going to be 5.75. I'll just squeeze it in down there because I'm running out of room. And if you put in your calculator, you'll get that answer. And now we're rounding off to 1 decimal place like we did before. And your answer will be 14.4, and it's metres squared. Okay, so we'll come back in the next video and just do a few more examples on this one.